All right, we are now on 7.6, applying the sine and cosine ratios. All right, just so you know, sine, S-I-N-E, is abbreviated on your calculator as S-I-N. That does look like sin. However, there's no sinning in geometry. So let's try to work on saying sine, whether we see it with the E or without the E, that's always sine. Cosine, and on the calculator you see C-O-S, cos, okay? So know that those are what the abbreviations are on the calculator. It's also the abbreviations we use over and over when we talk about sine and cosine in geometry. So just know that those are the abbreviations, but try to say them correctly, as in sine and cosine. So the sine of an angle, by the way, don't get scared on this. This is a Greek letter called theta, and it stands for, in this case, an angle. Just like we use x as a variable, we can use theta or some other symbol to represent something that's missing or something that's we're not sure of. So sometimes we might say sine of angle A or sine of theta or sine of 30 degrees. Whatever our angle is or angle's name is, that's what we put there. So don't get scared on that symbol. It just means a symbol. That's what it is. And it's a Greek one. It's called theta. So sine of theta equals, it's going to be a ratio of the opposite leg over the hypotenuse of a right triangle. So this always goes back to the right triangle, just like tangent did the other day. Cosine of an angle, or cosine of theta here, equals the adjacent leg over the hypotenuse. Okay, and we'll deal with more of these. I'll show you a lot of examples so you can see that. So we started with tangent the other day, and we're adding on to it sine and cosine, and you'll see in both of these use the hypotenuse. When we did tangent, it was always legs, opposite and adjacent. But now we are going to add the hypotenuse in. Okay. Some people find the next two definitions a little bit freaky, but this is kind of the easiest way to do it. So because I'm a terrible artist, and you know that, I didn't want to draw the eyes myself, so I found a picture online and pulled it in or whatever. But angle of elevation, if you're looking out your eye and you're looking straight across, that's your line of sight. If you have to look up to see something, you create an angle of elevation when you look up to see that. So when your eye normally would go this way, but now you look up, between your normal line of sight and where you look up, that's your angle of elevation, okay? Your angle of depression is when you look straight out your eye to your line of sight and you have to look down to see something. That would be your angle of depression. So just a tie-in here, remember our cardboard square. When I looked up the cardboard square to the top of the overpass, I was using my angle of elevation. When I looked down my cardboard square to the bottom of the overpass, I was using my angle of depression, okay? So the reason I define those and such, they're used in story problems. You just have to know when you draw the picture that goes with the story problem, how you need to draw it and where you put your angle, okay? And we'll work on that, so don't stress out on that. And if you can't draw an eyeball, it's okay. All right, so let's talk about these sine and cosine ratios. We're throwing them both in the same rule here together, but we definitely want to know the difference between them. And the difference is what leg they go to. Okay, so I'm going to do sine of angle A and cosine of angle A, so the same angle, so you can see the difference here. When I go to A, the ratio that's formed by the sine is the leg opposite, and the leg opposite over here is CB, over the hypotenuse, and the hypotenuse is over here, right, and that's CA. Okay, can our hypotenuse ever change? No. But can our opposite and adjacent change? Yes, depending on which angle we're talking about. So it's all about the angle you're at. I'm currently at A, so its opposite side is CB, and its hypotenuse is CA. When I go to do the cosine of the exact same angle, so I'm in the exact same place, but this time cosine is the adjacent leg, that's the leg it's touching over here, over the hypotenuse. So again, the adjacent leg here is BA, the hypotenuse over here is CA, okay? So sine, if you want to just write it one more time, is going to be opposite over hypotenuse, and cosine of your angle is going to be adjacent over hypotenuse, okay? So two of them new that we're learning today. All right, so let's go to the second page, and let's just practice writing our ratios. We did this with tangent the other day. We're doing it with sine and cosine, and it's important to kind of see where things are coming from. Okay, So we're going to start here with the sine of angle U. Always go to the angle you're talking about. Otherwise, you're going to get mixed up on your adjacents and your opposites, okay? So I go to angle U here. Before I start anything else, I'm going to mark that my hypotenuse is WU. There's only one and only one hypotenuse. It never changes. That means if I'm at U, the side that I touch on the other side is my adjacent, and the side I'm across from is my opposite, okay? So it's important to say, where am I? Which one's opposite, which one's adjacent. So sine is always opposite over hypotenuse. So opposite my U, I'm going to put the names first, is WV. My hypotenuse is UW, okay? I know I'm not going to require you to do that every time, but if you look back at these notes and you're confused, I want you to see those letters. Okay, my opposite number of U, well, that looks like it's 16. My hypotenuse is 34. Every ratio we do, we always say go to lowest term. So let's divide by, what, 2? I think that's about all I can do. I get 8 over 17. Can I reduce any further? No. Okay? So I go to my calculator and I divide 8 by 17, and I get 0.4706 because we're going to 4 decimal places again. All right. Now I'm going to W. Okay, so I'm still going to do sine, but I'm going to switch my triangle around because I'm going to W, okay? So now from W, the hypotenuse doesn't change, right? That's still the same. But now my opposite is across, and my adjacent here is touching. I definitely change which one's which. So opposite of W is UV. The hypotenuse is always going to stay UW because that cannot change. Doesn't matter which angle you're looking at. So when I go to the sine of W, across opposite there is 30, and hypotenuse is 34. I reduce again. I think, again, the best I can do is 2, and I get 15 over 17. 15 divided by 17, 0.8824. I think I'm going to round to 24 there, okay? All right, so finding sine, I have opposite over hypotenuse. Reduce it to lowest terms and get your decimals. You've got a couple of those on your homework worksheet today. Okay, so let's move down now and let's work on cosine. Okay, so for cosine, remember it's adjacent over hypotenuse, and I'm going to start with S. So once again, remember, here's my S. My hypotenuse is always across in the right angle and will never change. But because I'm at S right now, opposite is this 28 and adjacent is this 45. Okay, so cosine is adjacent over hypotenuse. Adjacent to S, so it touches the S, is line ST. The hypotenuse is SR. Okay, ST, so adjacent to S, that's 45. And my hypotenuse is 53. Does that reduce? No. So now I'm just 45 divided by 53, and I want to take it out to 4 decimal places. So I have 0.849, and I think I'm going to round to the 1. All right. Same picture, still cosine, but this time I'm going to go to cosine R. So remember, when I change angles where I'm at now, my hypotenuse never changes. However, now when I go opposite, I'm across there at that 45, and my adjacent becomes this 28. Because I changed angles, my opposite and adjacent changed, okay? But my hypotenuse never will. So for my R, my adjacent side is RT, and the hypotenuse will always stay SR. So when I go cosine of R, adjacent is 28, and hypotenuse is 53. Again, I don't think that reduces at all, so I'm just going to do 28 divided by 53 for my decimal, and I get 0.5283, okay? All right, one thing I want you to notice before we move on, my decimals. Are they ever bigger than 1? I just did 2 sines, 2 cosines, and every one of my decimals is smaller than 1. Think carefully here. What number always goes on the bottom of all my sines and all my cosines? My hypotenuse. And when you put hypotenuse on the bottom, and hypotenuse is the biggest side every time on a right triangle, I'm always going to have my biggest number on the bottom. So therefore, my sine and cosine will always be smaller than 1, okay? So I'm just going to write you that note over here in the margin. Sine and cosine will always be smaller than 1, okay? So that's just kind of a quick note, and I'll bring it back up again in another set of notes, and you'll know why I bring it up then. But the reason I want to tell you that is it's a way you can kind of check. Sometimes when we get into this sine and cosine tangent, this trigonometry, we start getting these numbers, and we don't even know if our numbers make sense. But that's one way you can say, do my numbers make sense? Are all my numbers smaller than 1? And they are. Okay, so we're good on that. So let's come down here on our checkpoint. We're going to look at one triangle. We're going to find sines and cosines on the same triangle. Okay, so I'm going to start with sine of B. And that means I'm going to angle B. Okay, my hypotenuse never changes. Sine is opposite over hypotenuse, so just a quick reminder there. So my opposite number is 21, and my hypotenuse is 29, okay? Because that's opposite my B, adjacent would be this side. And let me make that legible when somebody reads my notes. Okay. Because I'm already at B, I'm going to go ahead and find the cosine of B at the same time, because I've already marked angle B with adjacents and opposites and hypotenuse, so I don't have to remark it. So for cosine of B, I want the adjacent over the hypotenuse. So the adjacent is this leg right that it's touching, the 20, over the hypotenuse, which is 29. Okay, so there's my decimal, my fractions, right? Okay, let me go get my decimals. 21 divided by 29 is about less than 1. Remember, 0, 7, 2, 4, 1. 20 over 29 is about 0.6. That's not a 6. 0.689, and I'm going to round to 7 right there. Okay, so those are my B values. Okay. I'm going to switch now, and I'm going to go to angle C. So now I'm going to find sine of angle C. So when I switch here, I know that my hypotenuse is never changing, but my opposite is now the 20, and my adjacent is now the 21. So that's what I want to keep remembering, that because I changed angles, my opposite and my adjacent are also changing. Okay, so sine is opposite over hypotenuse. Opposite my C is 20. Hypotenuse is 29. All right, let's find the cosine of C. That's adjacent over hypotenuse. So my adjacent switched when I went to C. Its adjacent side is 21, and its hypotenuse is 29. Okay. Well, lucky for me, I already know those decimals. 20 over 29, I bet it's 0.6897. And when I do 21 over 29, that's about 0.7241. Okay. Did I get all numbers less than 1? Yes, so I must be on the right track. One thing I want to show to you here is I was able to use decimals from above, because look at the sine of B is the exact same thing as the cosine of C. And then when you look again, something like the cosine of B is the exact same value as the sine of C. Why does that work? Because sine's opposite side is of B's opposite side is C's adjacent side, right? And B's adjacent side is C's opposite side. So it makes sense that they kind of switch numbers, and then you kind of get the same answers for a different value, because the sides don't change. But if I call them opposite and adjacent, they do change depending on what angle I'm talking about. Okay. Now that we kind of know a little bit more about sine and cosine, where we get those values, we're going to start solving with them like we did with our tangent when we were trying to find different heights and stuff like that, okay? One of the key things, though, I need to tell you and warn you about is when we learned about tangent, we learned about one thing, tangent. And every problem was opposite over adjacent, every one of them. Well, today I just taught you two new ones, sine and cosine. And we already know tangent. So we now have this problem. We need to stop and say, wait, which one do I use? Okay? So let me introduce you to a little bit of, you can call it what you want, little language here that I use with my trigonometric ratios, okay, trigonometry. And as you do these problems, when you hear me in class, I'm often going to look at you and say, hey, stop and think. Which one do you want? Are we going to use so, ka, or toa? Okay? That's my language here. So, ka, toa. We're doing a little so, ka, toa work, okay? So, what does so mean? So means sine of the angle equals the opposite over the hypotenuse. Notice the SOH, so. Ka is cosine of the angle equals the adjacent over the hypotenuse. Ka, C-A-H. Toa, that we learned the other day, is the tangent of the angle equals the opposite over the adjacent. That's T-O-A, toa. So, ka, toa. So what I'll ask you as we go through these problems is we're going to stop and find out the information we know or we're looking for and say which one of these, so, ka, or toa, are going to be the best option to solve for our missing piece. Okay, you'll notice I also have that little note in the margin already. It says make sure your calculator's in degree mode, okay? We talked about it the other day. If you have a calculator that you're not sure how to get in degree mode, make sure you bring it to me, show it to me, and I'll be happy to show you how to move between the modes, okay, and how to get it in degree mode. Lucky for us, a lot of our calculators default to degree mode, so most of them are already in that mode, but if not, we want to double check and make sure we get it that way. Okay, so we have a basketball court here. It says you walk from one corner of a basketball court to the opposite corner. Write and solve a proportion using a trig ratio to approximate the distance of the walk. So they happen to show us here on this basketball court that the length of the court is 94 feet. Over here in this corner, they gave me a 62-degree angle, and don't forget we had the right angle over here. And they want me to find this hypotenuse, okay? So this is what I really want you to stress when you start working on these problems. Here's my angle. Across from it is the opposite. I'm looking for the hypotenuse. So when I mark those, I say, oh, I see an O and an H. What uses O and H? So, ka, or toa? Well, so does, okay? So I'm going to go to so, which is sine, okay? And I'm thinking I set up sine of the angle equals opposite over hypotenuse. Okay, so sine of 62 equals, what's my opposite? 94. What's my hypotenuse? X. I've used my trig ratio to set up my problem. Now it's time to solve for x. Remind me, can I solve for x when it's in the denominator? No, we can't solve for anything in a denominator. So first I have to get it out of the denominator. So I'll multiply by x to get it out. When I multiply the right side by x, I have to multiply the x side by x, the left side by x. X times sine of 62 equals 94. Okay. Remember, I want x by itself, so now I have x times 62, sine of 62 equals 94. How do I get rid of the sine of 62? I divide by it, and I divide by the whole chunk, okay? Don't worry about anything yet. So I get 94 divided by the sine of 62. All right, is x by itself? It is. Remember from the other day, I would call this my standardized test answer. That's how I would leave it on my standardized test. But we have a handy-dandy calculator in degree mode. So we're going to type in 94 divided by the sine of 62. Remember, sine is SIN on your calculator. We're in degree mode, and we get x is about 106.5, okay? All right, quick reminder. If you don't have a calculator like the one in class where you can do this, if you need to change sine of 62 into a decimal, okay? So for some of you, you have a calculator where you need to type in 62 and then hit the sign key, and it gives you a decimal. Make sure you write that decimal out to 4 decimal places, okay? so like 0.8829. And then take 94 divided by 0.8829. And you'll also get 106.5, okay? Quick note, let me try it here. 94 divided by just 0.88, I get 106.8. If I tried 94 divided by 0.9, because that's how you could round it to one decimal place, I get 104.4. Is that a very different answer? Yes, we're off by 2 feet. That's a lot. So please make sure if you're turning your work into a decimal that you leave 4 decimal places in your work. Your final answer can have 1 decimal place, but if you're using a decimal in your work, please leave it to 4 decimal places, okay? So we get about a 106.5 for my distance here across the court. All right, so let's try the next one. You're at the top of a roller coaster 100 feet above the ground. The angle of depression, so remember, we're looking straight out with our eyes, but when we look down, okay, this angle of depression is 44 degrees. Our height of this is 100 feet. And remember, we can take this height and move it over here. That's what they did in the picture. And we end up with this nice 90-degree angle. It says, how far down the hill, or how far do you ride down the hill? So X here. So once again, I'm going to stress to you, always ask yourself, from my angle, what pieces do I know, or am I trying to figure out? So across from the 44 is 100. That would be my opposite. My X is my hypotenuse. So I have the opposite. I'm looking for the hypotenuse. So again, SOHCAHTOA. It looks like I have an O and H. That's my SO. So I'm going to go back to sine again. Sine of 44 equals the opposite over the hypotenuse. What's opposite 44? 100. What's my hypotenuse? X. All right, can I solve for exponents in the denominator? Nope, so I multiply both sides by it. This side cancels, and I'm left with 100. Now I have x times the sine of 44 equals 100. How do I get x by itself? I divide by sine of 44. So what do I do to one side? I do to the other. And what I end up with is a mess. Let's see if I can come back to where I was. I did not, so I'm going to stop this video and restart it, okay?